Good evening, everyone. Good evening, everyone. Okay. Welcome to the 101th video on misconceptions in physics. Yesterday was a great day for me because I was able to reach my target. Today we'll continue with the same one. So as we know, we had been discussing on forces and several videos on rotations. I think we already done with. Still some more is pending, but maybe once I finish this forces, I'll come back to this. Okay, so my name is Ratankar Rao. I teach physics in an international school, and my passion is to teach. And a consequence of this, for the past 2 decades, I have been teaching physics for a various set of students. So currently, I teach for IBDP courses. And while I teach, I have a hobby, as I have been mentioning in the previous videos also. The hobby is that while I look at your papers, I see to it like which of these problems are incorrect and whether these problems are being incorrectly been answered by many of the students. That's what I look at. And then I ask the question, so why was this particular question answered incorrectly? What could be the reason? Then the reason I get is that maybe there were two concepts which were very similar. And as a result of this, okay, the students got confused. And hence, instead of applying one concept to a given context, they had applied a different concept. They got confused with the context. So then I felt maybe if we are able to train the students in such a way that we don't only explain the concept, but also explain the misconcept and in what circumstances can this concept fail, in that case, it will be very useful. So that's the result of all this. So far 100 videos already been completed. Okay, only in the chapter on mechanics. You can get all these videos from my website, which is ratankar.com, and still hoping to do more number of videos, okay, to get to know about it. And if you have any more questions on the any problems that you have, any numericals which you are unable to solve, you can always mail me back, or you can send me a WhatsApp message. This is my WhatsApp number. You can send me there. So even then I will be able to happy to answer you. Okay, so with this brief introduction, let me continue with today's talk. Okay, so today's talk is focused more on forces, and the question that I ask here is can the tensions be added? So this is what we are going to look at. This is a popular question which has been asked in many of the examinations, many of the competitive examinations, especially as an MCQ. Now let me start with this. If two ends of an ideal rope are pulled with forces of equal magnitude of 100 Newton in opposite directions, the tension at the center of the rope must be. There are two responses I usually get for this question. Both the responses are incorrect. Nobody gives me a correct answer. Now, the first response I get is since two forces are acting in opposite direction, the total force is 200 Newton. Okay, so the students who do this one, they don't even consider that force is a vector. They just say, okay, if I have 1 kg mass here, 1 kg mass here, I can add these two to get an answer of 2 kg, which is completely incorrect. Then, some of them also give me an answer saying that if you are pulling this force and if you are having one more force over here, 100 Newton here and 100 Newton here, then at the center, if you ask me what is the force, the net force equal to 0. Obviously. Now, what was the question? Now, read the question correctly. The question that is being asked here is not, okay, to something like what is the resultant force. Now, the question asked is what is the tension at the center of the loop? What do you mean by tension? Is tension and the resultant force, okay, are they one and the same? That's a question we need to ask. Okay, so when I ask you the question of what is the resultant force, then definitely this is your answer. I don't deny it. So you got confused with this. This is a misconception. Now, tension is nothing but the pulling force. Now I am sitting here. Somebody is pulling my hand like this. If you ask me what is my tension of my elbow, then the tension acting at here is nothing but the pulling force. Okay, though there is a friction here. See, I'm sitting on the chair, and because of this, I'm not able to move. Okay, but now let us say, for example, if my left hand is also being pulled in the other direction, then if you ask me what is my tension here, what is my tension here? The tension here at this point is nothing but it's being pulled like this by 100 Newton. And here at this point it's 100 Newton once again. So I should be only replying, okay, one force as what is the tension, who is pulling me, and with what magnitude. That's what I should say. So in other words, if you ask me the tension at this point, I can say, now I have been pulled by this force with a force of 100 Newton. Agreed. But what about this force? This force is also pulling me with a force of 100 Newton. That means my tension, whenever I talk about tension, tension is always 100 Newton here. And what is the result of these two pulling forces? The result of these two pulling forces is the object is unable to move, or the value of the resultant force is equal to 0. That's nothing but your resultant force. Now, some of you might have a question in mind saying that, sir, it's all fine, but suppose I have an object like this, I have a thread, or maybe I have a rope. Here I am going to pull it with 200 Newton. And here I am going to pull it with 100 Newton. Now, can you tell me what is the tension force? Will it be 100 Newton? Will it be 200 Newton? Will it be 200 minus 100 Newton? What should be your answer? Okay, at the center. Now, let us look at the difference between these two problems. In this problem, what was the acceleration of the particle? It was 0. The particle was not moving. The rope was not moving in any direction. But if you look at this here, now the rope is now moving like this over here, right? Because this force is larger. Let me call this as A here. Let me take up this center. Let me assume the center doesn't have any mass. Now let me draw the free body diagram for this one. If I draw the free body diagram, so I will say a force of F acts over here. And as a result of it, if I consider this is massless, the object is massless, okay, then I can say that this F is equal to M into A, where M is nothing but, okay, the mass of the rope, the entire rope. However small you consider, there should be some amount of force over here. Okay, so therefore, the pulling force in this direction should be equal to 200 Newtons only. I cannot, if I say it is massless, okay, I will not be able to say anything here. Okay, and thus the pulling force in this direction is 200 Newton. So now this is nothing but your tension along this direction. If I pull it like this with a force of 100 Newton also, then the pulling force in this direction would be 100 Newton. Okay, so when I talk about a resultant force, then I should subtract one from the other and give you the net value. Until and unless I don't speak about the resultant, there is no point in saying the tensions is nothing but two tensions can be added. Okay, so there's no point in adding two tensions. So that's what is the question. It says, can tensions be added? If the tensions are added, no. Okay, you may not get a probable result. But still, some of you might have another question. Sorry, if that is the case, see, this is a question which usually I get it. If I have a rod like this, and I have two wires supported by this way. Now there is tension T1 here, there is a tension T2 here. Usually these two tensions will be equal if the strings are same. And your mg weight acts here. Now can tension be added here? Definitely tension should be added here. Why? The reason is both the forces are acting in the same direction. And then the sum of the upward force is equal to sum of the downward force. And hence, okay, you are adding it. But now, when you add these two tensions, what do you mean by it? You are now finding out what is your resultant force. What is your resultant force? In order to get the resultant force, now you say the resultant force is nothing but T1 plus T2 minus mg, right? If this is seen to be in equilibrium, then T1 plus T2 minus mg will be equal to 0. Upward force equal to downward force. But did I ever say that, okay, what is the tension here? If I ask you, let us say this is the points A and B. Okay, if I ask you what is the tension at this point, what will you say? You'll only say the answer here is it's only tension. I have been pulled by a tensional force equal to, pulling force here is seen to be T1, maybe around 7 Newton. Okay, I was disconnected initially. So I have rejoined once again. Okay. So now as you see, okay, if I think I was describing this object. I have an object and then I ask you whether tensions can be added here. Now, when you add this, your resultant you get here is T1 plus T2 minus mg. So what did I answer? I asked you, what is the resultant here? Okay, resultant, not the tensions. So tensions here are additive in the sense to find out the resultant. Okay, tensions are being added over here to find out the resultant over here. So as a result of it, whenever you say about resultant, you can add it. Otherwise, tension. When I say tension, tension is only one pulling force. I hope, okay, this concept is clear. So therefore, if you ask me what is the tension at this point it's 7 Newton. At this point, what's the tension? It's only 8 Newton. I cannot add, or I should not add. If I ask you the question, what is my tension at point A? I should not say my tension at point A is nothing but 7 Newton plus 8 Newton minus mg, which is incorrect. Okay, so I should only specify how am I being pulled. Okay, I should not say, okay, so what is the resultant force acting on me? That will be incorrect. I hope you understood this concept. This is a very important problem. Many of the examinations I have seen these kinds of questions be asked. Might be the question can be a little bit tweaked also. Instead of asking like this, the question can be asked like this. You have a table, you have a pulley here, you have two pulleys connected over here like this, and then there is a mass and there's a spring balance connected over here. There's a mass kept here, and then you keep it like this. Okay, and now I'll add 200 or 20 kg weight here. I'll add a 10 kg weight here. And then I will ask the question, what is my tension acting at this point? The tension acting at this point is nothing but 200 multiplied by 10, which is 200 Newton. 20 multiplied by 10, 200 Newton. If I ask what's the tension at this point, the tension at this point is nothing but 10 multiplied by 10. Okay, I'm sorry. This is, oh, it has a mass over here. The tension here would be different over here. Okay, so then you need to find out the tension. You can use your free body diagram concepts to get the value of it. I hope you have understood this. If not, do write back to me. So let me put it across with some more examples how tensions are determined. Okay, because tensions form a very important role. Okay, whenever we're discussing problems in rotation. Okay, fine. Thank you, friends, for watching this video. If you like this video, do share, comment, and subscribe to my channel for further updates. So this will also be an appreciation for me and to make more number of videos. Thank you.